Each year, Microsoft Research hosts hundreds of influential speakers from around the world, including leading scientists, renowned experts in technology, book authors, and leading academics, and makes videos of these lectures freely available.
Right. Well, thank you for being here for the last session. So you are still on the future web track for those who remained here. For the other ones, this is a whole day track where we looked this morning at intelligence, the topic of intelligence. More recently, the topic of privacy and trust. And now, for this last session, is going to be back to Bing, but looking at another type of medium, which is not text, but maps. And first of all, I want to say we have a change in the program in terms of speakers and a little bit topics, but not too much though. Blaise Agara-Arka was enabled to come at the last minute, and he's very sorry about that. And we are very fortunate to have members from his team who stepped up to give us great demos. And just to set the context here, who knows about Cirque du Soleil? All right, yes, Canadian company, French title, what's not to like, right? And they're actually at Marimo Park right now, and which is in Redmond, very close to Seattle, and I went to see them, and this last session reminds me a little bit of that. It's like watching these acrobats and, you know, doing highly trained people like we have here with Eyal Ofek and Greg Schechter, very, you know, highly trained people, and going to do, you know, they're going to do this acrobacy, and some of them may be like, you know, but they will work without any net there. So please, let's welcome them, and thank you for being here.
Thank you. Thank you. Yeah, I'm Greg Schechter. Eyal Ofek is here, and he is going to be joining, taking over where I finish off in a little bit. We found out about doing this presentation a few hours ago, so this is going to be a little seat of the pants. But it should work out because we've got good stuff to show, so I hope that will be of interest. We don't have, at least I don't have a ton of material, so please feel free to shout out and ask questions and raise issues and stuff like that. This is going to be a little different than I think I saw. I briefly saw the abstract of what Blaise was going to present, and this is going to touch upon aspects of that. It's not the exact same talk and discussion. So I'm architect on the latest version of Bing Maps that we released actually back in December. And what I wanted to talk about and really just show people was what we've done and what the opportunities there are for people in the academic community and elsewhere to take advantage of what we've done and build upon it. So this is really, these are my slides, this one and this one. Right now we're on this one. So, but I'm going to switch over for the rest of the presentation over to a demo. And let me just make this full screen. Oops, wrong F12. Okay, so what we see here is the latest incarnation of Bing Maps, which you can reach via bing.com/maps and bing.com/maps/explore. Bing.com/maps, you'll see a offer to try the latest new version of Bing Maps that takes you to this. And what I want to show with this really is what we've built here is a version of Bing Maps that's really intended to be kind of a trellis or a canvas for presenting spatial information. And we have a bunch of what we call first-party experiences, spatial experiences here, driving directions, general search, et cetera, and a number of applications that build on this canvas. And we've opened up the system for others to build on it as well. And I'm going to give examples across the board there. So this is your basic 2D map navigation. You'll see the first thing that you'll notice right off the bat is that it's extremely responsive compared. This is using Silverlight technology, and it's very responsive compared to what's generally available in browsers. And if I go down here, what it's using is a technology called Deep Zoom, and it's a multi-resolution rendering technology. And the way it works is it just downloads what's necessary for what's in the view at any given time. And the complexity, you can imagine, I mean, you know we're looking at the world here. So there's a lot of data, but at any given point, the data being displayed is really only, and the data being accessed from the network is really only the data that's needed to render this particular resolution, this particular viewport in there. So as I move down, we'll see transitions into different modes. Right now we believe that at this mode, you typically want to see kind of a street layout. Higher up, you might want to see an aerial or satellite view. A little further in, you want to transition to more of this 3D-like view, but it's not really 3D. What we'll see, let me just zoom in a little bit more there. What we'll see is that the view here is really a synthesized oblique view that gives you a bird's eye view onto the world. And this is available throughout the world. And the way this is generated back on the server side by taking satellite imagery that has, not satellite imagery, airplane, overfly imagery that has been taken from 4 cardinal directions. And then back on the server side as a batch process has gone and generated these effectively 3D oblique views. So you get a really nice way of looking at the scene. And you see it still has sort of a SimCity-like look because it is an artificial view. So if I zoom in a little bit more, we'll see in a second, transition into what actually is real photograph in bird's eye view. So my SimCity-like artificial view is gone. We're in close enough that we see actual imagery that was taken from planes at 45 degrees, and I can go and look at it from a different direction. And you see that as I make this transition from one place to another, it's doing kind of a warp. And that warp is because you're really having different flybys at different angles that are coming through that warp right there that you saw. So there's some fun kind of statistics around this. In this type of view here, this aerial view, in fact, I can turn that on for everything, this aerial view. There's, let's see, we obviously don't have all parts of the Earth photographed at the degree that we have here, but of what we do have, there's, let me see if I can get this number right, 500 billion, yeah, about a half a trillion aerial tiles, and tiles are 256 by 256 square bitmaps, which amounts to 30,000 trillion pixels and about 30 terabytes of storage for storing this stuff. So it's a big data problem on the back end to collect and manage and process and store all of that data. And then, of course, to serve it up because it's happening in real time as we go. Now, as I go back in here, let me pull this back up, and I'm going to run a little application. Here I clicked on this map apps, and there's a bunch of map applications that are available. I'm going to click on one called What's Nearby. And what What's Nearby does is it brings up imagery, I mean not imagery, it brings up points of interest that are in a particular region of stuff that you might be interested in various businesses, categorized in the way that you see here. Restaurants, coffee shops, taverns, etc. If I go down further, everything maps properly, and I can click on this little blue dude over here. Yep. Oh no. I swear I've got a network here. Let's try that again. Okay. Pardon me, I'm going to try to refresh this here. Just Streetside. Yeah, if I don't have network access, this is going to be interesting. Okay, we're going to switch. We're going to switch PCs for a second to PC 2. Al, for some reason, has access on his machine. There we go. Okay. Great, thank you. So I'm going to pop back out again briefly. And what we saw here was this is our what we call Streetside Coverage. And we zoom in, and what you'll notice is, you know, as I'm sure you're aware, our main competitor in this space, Google, has popularized Street View and has broader coverage in a number of places. But one of the things that we think is a real added benefit is the transition and the continuous transition that you get between map modes, as we're seeing as I move in and out, then go back here, transition into Streetside, just that smooth transition that's not losing me. I knew exactly where I went. I knew as I moved down. In addition, as I move forward and start to navigate along the map, you'll see that we're not just doing a simple fade between the imagery. What we're doing is we're using what's called simplified geometry. And you see the things breaking apart a little bit. That's because we're doing texture mapping and rendering onto polygons, a relatively small number of polygons, 100 or so polygons, that then results in giving a much better sense of space and movement as I move around. So I had dropped the what's nearby, but you know the idea is that the what's nearby application happens in this context, continues to happen in this context. So this is all sort of the basic aspects of a system that you'd expect a company that's delivering online mapping to be delivering. But in addition to that, one of the things that we've really strived for here is, as I was talking about, to be able to treat the mapping surface as a trellis for building other information on there and exposing other spatially relevant stuff. So as an example, let's take a look at the photosynth application. So and let me come back out. Do folks know about the photosynth technology? You've heard about this technology? So photosynths are collection, and I'll just show a great example. It's much easier to show than to describe. So here's a great one right here. What I'm going to do is, this particular one has been created by someone, this Pike Place Market in Seattle photosynth. Someone created this and geolocated it, registered it in Pike Place Market in Seattle. And what we see here is something that's been contributed by the photosynth user named the Bobo. Has 158 photos that this person took, submitted them to the photosynth website. What the photosynth site does is it analyzes these. And it analyzes them and makes them really blurry like that. It's really good at doing that. Well, I don't know what happened to our network here again. Okay, maybe it'll come back when I come back. But another thing I can do with that is it's done the 3D reconstruction, basically, from the 2D imagery. It's done 3D reconstruction and built effectively a model of what that area looks like where the pictures were taken. So as I move around here, we see the cameras that have been deduced from the analysis that are coming from the point of that cone and pointing in the direction that the cone is pointing. And so AL just plugged in the network cable, so that maybe that'll help us out a little bit. Let's see. Yeah, so one of the things that, back. Okay, that's better. So one of the things that we're seeing are, so here, now we have better resolution. So I can click on a particular highlight that the author of this created, buskers down here in Pike Place Market, and well, that's a problem. So maybe this will come back in a second. One of the things that we're able to do, though, is these applications. And you saw a brief, there's about 30 or so, 40 or so applications in the application gallery of this system right now. And those can be written by third parties. We have a developer portal that's available for third parties to come in, for other people to come in, create a map application that has access to the map, can put stuff here on the pane, the left-hand side, put stuff on the map, take over this surface, and register themselves as an application available on for any Maps user, any Bing Maps user. Let me see one more shot of this here. So you can see what this application has done. It's effectively built a 3D reconstruction of the scene here, just from the content of the photos. And what AL will show, provided our network continues to work, is some additional applications of technology like this. Let's come back over here, remove that. So the few other ones that I wanted to show here, something like Twitter Maps. Now what this does is we've brought in a feed. This is, where you don't necessarily think about a Twitter-related application in this context, but tweets are more and more getting geocoded upon their entry through mobile devices. They get located with lat and long information. So these are the most recent tweets in 100 most recent tweets in this area. And I can click on one and see what's going on in my particular neighborhood. There's going to be interest in, in a neighborhood that I'm in. I want to find out what's going on in that neighborhood. And this is a place where it's effectively a mashup, right, of a spatial canvas like I talked about and a Twitter feed. You can see other things like, where's local lens? here. Local lens is a related thing with respect to social media, where we have 1,000 or so blogs that get regularly crawled in real time, really, and text extraction happening on those to determine web content that relates to particular areas. And then we're able to map that to, hey, here's the blog contents that have referenced Capitol Hill. They may be from a Capitol Hill blog, they might be from another blog that reference Capitol Hill in some way or another. So again, we're able to use social data, social media, and mash it up in conjunction with maps. Another great example of this is this, which is a fun one. This is the Newseum.org. It's a third party that we've worked with that provides a data feed with newspapers from around the world. And they collect the newspapers, the participating newspapers basically scan and submit their front pages. So if I hover over a particular one from Casablanca, this is today's front page from Casablanca. And what's their incentive for doing this? The Newseum.org who wrote this, they basically get traffic driven to them because I can click on this and be directed to their site. Now, most of these that I've shown thus far are kind of one-off applications, and they're based on 2D spatial representations of things. So there's another class of applications, like, and this Bing Health Maps is an example of that. Let's choose state of Washington, say. It's going to zoom me into the state of Washington. And this was done by Microsoft Health Group, where they're collecting different, they're using a data feed that shows different health indicators. So health risk factors, consuming few fruits and vegetables. That's a statistic and data that's available. So you can imagine this mashed up with another application that shows fast food restaurants, for instance, right? And gives you an insight and visualization beyond what you would get from just tabular presentation of such data. Oops. And an example of that mashup sort of a thing is one of the, where is it? There's a Tour de France application here, right there. And this was created, obviously, you know, it makes the most sense this month right now. It's got a bunch of information about the Tour de France. But one of the things I can do with this is I can simultaneously launch the Twitter Maps app and go back and say, hey, I want to look at both of these things. And in addition, I want to, say, filter out the Twitter Maps for everything with tour in it and only tweets with photos. So that's going to change what's there quite a bit. So what I've just done is I've done sort of a user mashup. You know, typically we think of web mashups as things that application programmers generate. They pull data sources from different places, they put them together into a single application. This I'm doing a mashup as a user on a consumer website. I've launched 2 applications, thought that there were interesting pieces of information to correlate, and now I've got this Tour de France relevant information as geolocated tweets along the route, which is kind of a nice a nice side effect that neither application developer had intended. So this is also not just, I had mentioned earlier, not just about 2D. So another very interesting one to do. Let me do this. Come back, let's come to Manhattan, say. And I'm going to drop back into our street side view. So here I dropped in not far from Central Park. And I'm going to run the Worldwide Telescope map app. Now, Worldwide Telescope is developed by Microsoft Research as a Windows client application, as well as a Silverlight website to go visit. The Worldwide Telescope team did a bunch of work in conjunction with us in Bing Maps. Actually, not even a bunch of work, some work to modify or enable their application to be used within here. So one of the things that I can now do is, okay, I'm on West 56th, moving along the street, and one thing I can do now that I've launched Worldwide Telescope is look up and see the constellations that are really there right now. You know, if someone turned out the lights, this is what you'd see. So Saturn's out here, and I can go and scrub time, so see how the constellations change over time. And this was a relatively straightforward addition to the system. So, you know, I can also take advantage of what Worldwide Telescope's all about and zoom on out to Saturn, if I don't lose it. I think it's not really square there. So here's Saturn, and I can. Oh, that was a quick transition. Oh well. So that's what's available there, and then I want to finally go to my second slide, which is on the other machine. And the site that I just showed you was this one. Oh, the blue's kind of hard to see, huh? So bing.com/maps/explore is this website, and everything that I just showed is all available on the live site and ready to run. These apps, we came out at the beginning of June with a public SDK where anyone can go and register to use the SDK, and a developer portal along with that. So what you do is you visit that site, connect on Microsoft.com/BingMapApps, and download the SDK from there. With that, you can create a Silverlight, using Visual Studio, create a Silverlight library, which you can then test out locally just on your machine without submitting anything against the live running site. There's a parameter that you can use to let you access the stuff you created locally. And when you're happy with that, you can visit a web portal, upload what you've created, and we'll take a look at it, make sure that it's kosher from a security point of view, and hopefully ship that out and make it available again to every user who's using bing.com/maps/explore. So with that, I'm going to transition over to Eyal, who has some specific aspects to discuss on some of the technology used here.
Can you just run the Can you hear me? Ah, great. Okay, so I thank Greg for showing us the platform in general, and I will focus on more research. I'm managing a research group within Virtual Earth, and let's show you 3 different projects that eventually lead up to an application, like one of those plugins that you can see there. So let's start with the first one. Okay, so that's my name. And all right, so the first application that I will look at is we released last year was to take user photos, for example, from Flickr, and to show them in their context on the streets relative to our images. So why do you want to do that? First, it's not, we look at Virtual Earth or Bing Maps as a platform which unifies different informations based on location. Let's say that someone somewhere took a picture, and that picture shows on the side shows my house. I'm actually quite interested in it. But it's really difficult for me to find out that picture. It probably doesn't have a name that relates to my house. It's not a special house somewhere. And it might look based on the GPS where the photographer might stand, but it might look in a totally different direction. So it would be nice if we can take as much information as we can find out there, whether it is traffic cams and photos and videos that people share, and FaceTime videos, and put them in one uniform environment, which we can access by location. Here, for example, are 4 images from Seattle, taken from Flickr, and some of them I can recognize. The public market is quite a famous one, and I know where it is. Where is that house with vegetation? I have no idea. I don't really recognize every house in the city. But we want to associate them with a location in the city, and not just location, but also where was the cameraman standing, where he was looking at. So in order to do that, we need to take an image like this image of the public market and go around hundreds of thousands and sometimes millions of images like you see on the bottom, which are 360 representation of some location on the street, and try to match them. And you can see that there's several problems. For example, that although this sign is very notable, is quite small in that image. That image has totally different geometry than the image that the user took. Maybe it's, the user took the image at night. Maybe there was a person in front of that image, and all sort of problems that will make that solution hard. So we build a system that basically goes out, look at each image, extract invariant features, those features that hopefully stay the same regardless of changing of illumination and orientation, and try to find it within that's where geometry of the 360 images, and need to do that efficiently. And why is that so? Let's say that the user give us an image and did put it on a map. He went to, say, Flickr, and he pushed a pushpin and say, I was there when I took that picture. The fact is it's not that accurate. Users tend to be mistaken, sometimes a block away. If you put in a GPS of the photo, it also tends to wander, especially in urban canyons. It could be 30 meters away, it could be more. And within that radius, there's actually could be a lot of those 360 photos that we went out and captured, and we need to go out and find the place where this will fit the most. So in order, I won't dive right now into very technical issues. If you want to ask me, I could describe them. But basically, we build up a sparse representation of the environment that will make that search fast. So basically, we take candidates, we find the one which is most matching, and we actually see for our application, we didn't need to match every image, but we wanted to really, really get only good images. We matched about 60% of images that we have, and but what was really, really important for us, that will be almost no false matches. So we're there and around 99.5. So then you could go out and look at the images and see them in the context. So let me show you that. So I'll remove all applications up till now. And this is an application you can play with. It's called Streetside Photos. And basically, I can take images from Vancouver or San Francisco or Seattle that we matched, and let's look at this one, for example. And we go to that position where this image was taken and show the image at the location. If think this one is even better. So, or if I go right now to, where's my mouse? I'll go to Seattle, and let's go to one of the most famous places in Seattle. Okay, to Pike's Place. So it's near the sea here. There. Okay, and let me go down to the street. Everywhere I go around the city, it will show me images that users of Flickr pasted on or took in that place. And I can see sometimes it's very old photos. I think this one might be even older. So even as I walk on the street, I can see how this one was, this one is 19, almost 100 years ago. I can see how it looks at night. Or what different things happening here, whether there's protest or let me try to, someone played with that image to show it differently. And even just looking at what people are taking at that, what images people are taking at that place. Okay. So I invite you to play with that. There's a lot of images out there. Now, what most images out there are not geopositioned. Most people didn't went and push the push pin on the map. They just upload the image. Can we do something about that? So the answer is yes, we can. We took about 5 million images of Seattle, which we knew where they were taken because we took them with a car, and built an index for the entire Seattle, and then went to Flickr and just asked, give me images of Seattle. By doing so, what we could do is we can get look at, say, the first 3 most matching images to what we have. Sometimes it's noise. Sometimes we have an image that had a stop sign and we find other stop signs in the city. But many times we can find something which is like someone went in and put a push pin, and now we can start and look for a match there. So if we just search for Seattle, first thing that we notice is that only 13% of the images are actually could be positioned. Most of them are image of my dog or my room or a rock show, things like that. And out of them right now, about 10 of them we matched, again, with very, very high precision. And that's what you can see right now on the site. If we look at the distribution of where people take photos, it actually tells us a lot about the city. For example, this is a graph where the brighter areas are areas where people took more photos. And you can easily see that these are related to very touristic positions in Seattle. But you can do furthermore. Let's say that I'm taking all those photos, and I'm looking at each photo as a flashlight. And I calculated where each image is and which direction is that flashlight illuminating. What will be the most interesting things in the city? Probably the most illuminated object. So we can actually take all those flashlights and throw the light and accumulate it and get a function which tells us what's interesting in that city. And based on that function, we can actually associate the photos together based on what they're looking at, rather than where was the cameraman standing. For example, this is a set of images taken at the artist gallery. That's the area of the gallery. You can see that the most interesting object is somewhere over here. And if we actually look at the photos, this is where the artist was standing in front of a canvas drawing. And you can group together photos of the same subject. For example, artist tools, automatically, based on the fact that they're looking at the same objects in the scene. So then what we could do is we can take, for example, images and look at the name of those images, and we can find out that the sign that they're looking at is actually here. It's located inside the public market, and this is obviously located within Seattle. So we can build up a hierarchy of those photos. And given that, it's quite easy to find out which images shows the most interesting thing or the most photographed things at Pike's Place. Let me jump to a different application, text. Images includes a lot of text, images that are taken on the streets. That text might be from different languages, different fonts, but it has a lot of information in it. What can we detect that? Now, the fact is that finding text in images is hard. Before it's hard. Why is it used? For example, for search. As you can see, those books has basically very similar images. The only difference between them is the text. Or we want to navigate in the city, and the text there says whether we can go in that street or not, and when we can park, and so on. We might want to help visually impaired that go around and cannot read that text. We might want to do a translation. I worked for some time in Beijing. That's basically the first application I wanted there. We might want to know where the businesses are, because someone tell us there's the Starbucks there, but we actually want to bring you to the door of that Starbucks. Probably that door, on it there's a written Starbucks. So the first thing that you notice is that OCR, optical character recognition, on natural images is very different than traditional OCR. Traditional OCR assumes that you got black text over a white background, neatly organized, and has a limitation with things such as large variability of fonts, as we can see on the street. Or if the text is too short, it's hard to organize that text. If there's shadow on the text, or noise, blur, and also a weird organization that we can see text on our streets. And the fact that we might not see the whole text. So what we set out to find out is a filter that if we look at an image can come out and say, look, there's a text there, regardless of the language, regardless of the font. Okay, that was presented this year at CVPR. I'll just go fast over this. Most text detector nowadays has filters that go around and search for things that could be a text. One problem with that is that they're scale dependent. If you want to find out the small text there, you probably need to run another filter, or smaller text, and you could very easily miss text, and it might be slower. What we want to do is something that will be scaleless, and that will give us segmentation, give us that white page with dark text on it that we can OCR. And let me go directly to what we did. What we looked at was the fact that when someone writes down a text, regardless of what language, uses a tool, usually the text has a very almost constant width of the stroke. It might change, but it will change slowly. The variance of that change of width will be quite low. And we can use that feature to detect text. So for example, here's an image taken on the street, and there's a statue here, and there's a word and vegetation, which usually generate havoc for detectors. Let's look at the small part of that image. Here is a part of text and a background. What we could do, very simple, is we go for points that are transition from background to the text. That could be a point like this. And we look in the direction which is orthogonal to that edge, and look what's the width possible width of a stroke there. We do this for every point that we find that has an edge in it. And eventually we do an aggregation, find out the minimal stroke width for each pixel. And the result is, if we look at areas that has a low variance of stroke width, the text just pops out. So without knowing what language it was, we could say, oh, there's a text in here. Then we can do all sort of geometric check, finding out that the text has a consistent color and height, stroke width. We won't connect words. We'll connect words which are letters which are similar, but not bold ones or small ones or different colors or too far away. We will prefer straight lines over a curved one. And the result will be that we can actually go over the images and find out where's the text at. And this could be very fast. It can run on a phone just as well in real time. So let me show you an application that is a result of that. Let's go here. And again, sorry, I'm coming from Seattle, so that's usually the place we work on. Okay, so let's say that we're here in Seattle and we want to search for something. Let's say I want to search for an ATM. I'm searching for an ATM. And the fact is, most ATMs are not in banks as we think. They might be in... why is it not coming in? Now I'm getting the... Sorry. Let me rerun that. And while we do this, I will jump to another demo, and then we'll show you the other one. Okay, so this is something that we worked on and going to be displayed in 2 weeks at SIGGRAPH. As you saw before, let me remove this. We have a street side images. We can look around 360. And if we want, we can jump forward. Yeah, I hope we can jump forward. Jump here. Aha. Okay, no problem. Let's have another one. And let's take this one here. Me. Is this one working? Okay, so let me just show it from here. From here. No, I don't see anything here. Here. Okay. So I apologize, I wanted to show you live, but it will be somewhat from a video. So we have the ability to, just a minute, is it playing? Yeah. So we have the ability to show a 360 image. But then when you want to go down the street, you have to download the next image, and the next image, and the next image. This is usually quite tiring, and if you're on a phone, it requires a lot of bandwidth. So wouldn't it be nice if we had that street, and instead of going this 360 panorama after 360 panorama, we can actually look at the side and do something impossibly physically. We'll go far away, and we see the street. By this distance, probably our back hits the building on the other side. So this way, we can just get a flat out off the street. We can go and say, oh, that's the restaurant I wanted to be in. And if we just zoom in, we automatically go into the 360. And as you can see, now we spread the images. You can see that places that have depth differences, like junctions, you can actually see the parallax as you move around and scroll over that image. Okay. That's the problem with using a video. And just want to go to navigation in it. So basically, you can go around, and every point that you're looking, this guy right now is trying to find out a specific shop, and can find it. And you can think if you're having on your phone, it's very natural. You can just slide down the street, and it's very efficient from bandwidth. Okay. So, summary. What I want to just say, I want to say that Bing Maps right now has a new architecture. It's very much open to put in plugins that can do awesome things in real time for the client. It's and have an access to the data that we have within our maps, as well as could be access that other people generate within their applications. And I invite you to try to play with that. Thanks.
Right, thank you. Let's thank our acrobats of this last session here, Eric Schechter and Eyal Ofek. And I'm sure you can take a few questions, if there are some questions.
Okay. Yes.
All the examples...
Wait for the mic, please. Thank you.
So all the examples use the US, New York, Seattle. Do they work in other countries?
Yeah, so all of what we don't have in other countries, although we do have a little bit in Canada, are the street side imagery. We're working on expanding that coverage quite a bit internationally as well as within the US. The other map modes absolutely work internationally, the road and aerial, and obviously there's different degrees of coverage. There's less coverage in Mali than there is in France, for instance, but it is international.
Okay.
Oh, yes?
The mic, please.
Are there any plans to be more browser inclusive, either through other plugins or through working with the other plugin developers? Like,
so this is a great question about browser inclusivity. We didn't talk about, we showed our examples in IE. This works in Firefox and Chrome on PC. It works on Safari on Mac. Safari on PC I'm not positive about. So we've pretty much gone for the majority of stuff. We don't work... I don't believe we work on Linux systems.
Yeah, Mono barely does Safari or Silverlight 2.0.
Right.
No 3.0 definitely.
Right. Well, this is Silverlight 4 actually. So, but you know, we've really gone for reach as our primary issue, and the broadest possible market within our constraints of resources and time and such. So, thanks.
Any other question? So one question. So you are from Bing Map and mobile. Mm-hmm. So how much of the technology and applications you've shown us today are ready for prime time on a Bing mobile environment? And what are the challenges going there?
Well, yeah, so there is a Bing application, a Bing app that's available on iPhone, on Android devices, on Windows mobile devices that does have a mapping experience and shows aspects of what we showed here. It's using the iPhone, iPad applications use native implementation of that, and we're making a big push in the mobile arena. It would be different than what we showed here. but there's very much a big emphasis and push towards mobile, and we'll be talking more about it and also learning more about it ourselves as our plans solidify.
To talk about some research challenge there, or
there's quite a lot of research challenge, starting from the fact that we have to deal with a lot of data. We're talking about petabytes of imagery that has to be scanned out for privacy, removal of people, organizing photos, and many techniques that appears in papers but involve a little guidance from a user is cannot be used in this case. And we see more and more inputs of data coming from public, from mobile phones. So at least I'm coming from an area of computer vision, and in that there's tons of things that need to be done. But also areas such as data mining and organizing or finding out, learning out things that user wants or serving.
what about user intent?
Yeah.
Back to that. Mm-hmm. All right, any other question? Yes, okay.
Just out of curiosity, could you search for a car plate, for example? Because you have car plates, they are basically text, right? And you have a lot of cars in the street views, so you could actually search for a car plate.
Potentially you could, but we actually went out and erased all car plates and people faces, and we erased it. We don't have that data. I mean, when we deal with that data, it's already erased. So potentially you could, but it doesn't exist in our imagery.
And that was also a big, part of what Al's team has worked on also, the Bing Maps has worked on, is the technology to locate faces and detect do facial detection and license plate detection and blur those out.
All right, let's thank our speakers again.
Thank you.